For Unit 2, we're going to focus on equations and inequalities. So the first thing we're going to look at are linear equations. And the big difference between this unit and Unit 1 we only focused on expressions. So when we're talking about an equation, we're talking about an equation meaning it has an equal sign in it. A linear equation in one variable is any equation that can be put in the form ax plus b equals c, where a, b, and c are constants and a is not equal to 0. So an example of that would be something like 2x plus 3 equals 0. That would be a linear equation. 3x equals 5 would be a linear equation. 4x plus 2 equals 10 is a linear equation, and so on. So basically, if you look at the x term, the power or the exponent on the x is 1, and the coefficient can be any number other than 0. So that's a linear equation. The solution set for an equation is a set of all numbers that when you plug in for x, it makes a true statement. So if you look at this first one, 2x plus 3 equals 0, whatever number I can plug in for x that makes the left-hand side equal to 0, whatever makes that true is going to be a solution set. Another thing is equivalent equations. So equivalent equations basically just means when you have two or more equations that have the same solution set. So these examples here all have the same solution set of 7, which means they're equivalent equations. So when we look at solving linear equations, you guys already know when whatever you do to one side of the equal sign, you got to do it to the other. And the reason for that are these properties of equality. So there's the addition property of equality, which basically means whatever I add to one side, I can add to the other. So if you look at this example, A equals B, if I add C to both sides, it's still going to be equal. You can do the same thing with subtraction property of equality, just because subtracting a number is like adding on a negative. And then there's a multiplication property of equality, so whatever you multiply by on one side, you have to make sure you multiply the other side by that same number. Again, it works for division as well because dividing is like multiplying by the reciprocal. So basically, because of these properties of equalities, that's what allows us to solve equations. Whatever we do to one side, we do to the other, and we try to get x by itself. So here's steps for solving. We always want to try to get rid of parentheses first. We're going to use distributive property to do that. If we have fractions or decimals, we're going to do some tricks kind of to try to get rid of those and make the equations easier to solve. And then we're always going to combine like terms on one side and then combine like terms on the other side before we start moving things from one side of the equation to the other. Once you have that set, you're going to always use the addition property or subtraction property of equality to get all of the variables, meaning x on one side and all the numbers on the other. Then our last step is always to use a multiplication property to get x by itself, which is usually by dividing by the number. And then it's always a good idea to check your solutions to make sure that you have the right answer, that you found the correct solution. So let's look at some examples here. The first thing is just to show like how do we check something? So how do I determine if negative 12 is a solution to this equation? So really what that means is you need to take negative 12 and you need to replace it wherever there's an x. And when I check, I always use parentheses. So I'm going to plug in negative 12 in for x, and I'm using parentheses to make sure that I keep the negatives straight, basically, to make sure that I take care of the negatives. So I plug that in, and then you start simplifying. So remember, I'm looking at negative 12 times 1/3, which is really like saying negative 12 divided by 3. So that's going to be a negative 4 plus 2. And basically, you're trying to see if when I plug in negative 12, does it make both sides of the equation sign equal, or both expressions equal? So I'm trying to see if, in fact, if they are equal. So negative 1/4 times negative 12 is like saying negative 12 over negative 4. So that's going to become 3 plus 1. Simplify the left-hand side here, which is negative 2. And then over on the right hand side, we get 4. So since negative 2 is not equal to 4, that tells me that negative 12 is not a solution. So we would say, so negative 12 is not a solution. Okay, so now let's look at some actually like solving examples. So this example here, we want to solve this equation. So let me just rewrite it here. So we have 2x minus 5 equals negative 3x plus 10. So remember, we always want to get the variables on one side and the numbers on the other. It doesn't matter what your initial step is, meaning it doesn't matter if I move this 2x over or this 3x over to the other side. Whatever you pick, you just have to make sure that in the end you get x's on one side and numbers on the other. I always try to make it so that I'm not going to have as many negatives. So what I mean by that is I see this negative 3x, and instead of subtracting the 2x from both sides, I'm going to add 3x over to both sides just so that I'm kind of getting rid of some negatives. So now I have 5x minus 5, carry everything down, and we have 10. So now I need to get the x's by itself, so add 5 to both sides. So we have 5x equals 15. And again, we're getting x by itself, so divide everything by 5. So we get x equals 3. So that's our solution. And again, it's a good idea to check. I'm not going to actually go through the check, but remember to check your solution. You just plug it back in. So it's a good habit to get into, to check. All right, let's look at another example. Oops. So another example here is going to be something with some fractions in it. So whenever you have fractions, what you want to do to get rid of these fractions and make this equation easier is to multiply everything by the LCM, or the least common multiple between these numbers. So basically what you're thinking of is, what is the smallest number that 5, 2, and 10 can all multiply to get? So the LCM, I always check when I'm looking for this. I always check the bigger number. So in the denominator, the biggest number is 10. So I ask myself, does 5 multiply by something to get 10? And the answer is yes. Multiply it by 2. Does 2 multiply by something to get 10? Yes. Multiply 2 by 5, you get 10. And then 10 times 1 is going to give you 10. So that means the LCM is 10. So then what I'm going to do is I'm going to multiply everything by 10. Every single thing, because whatever you do to one side, you have to do to the other. You always have to be consistent. You have to multiply every single piece. So then what happens when you do this, when you do 10 times 3/5, some stuff's going to cancel, but I'm just going to first rewrite it like this, and then I'll worry about the canceling. So one thing I want to point out too, when you're multiplying a whole number by a fraction, you really need to think of this whole number as it being over 1. So it does not get multiplied to the bottom, it only gets multiplied to the top, which is another way of saying I can think of it as 10 divided by 5, since the 5 is in the denominator. And when you do that, you get 2. So you're going to be left with 2 times 3, which is 6. And then over here, 10 over 1 times 1/2 is like thinking of 10 divided by 2. So you're going to get a 5. 5 times 1 is 5. And then at this side, my 10's cancel, so I'm left with a negative 7. So now your equation that looks really complicated with all the fractions is much easier. And now we just have to work on getting x by itself. So we're going to subtract 5 from both sides. So we have 6x equals negative 12. Divide both sides by 6. And we get x equals negative 2. And again, you would check your solution, make sure it works. For linear equations, your solution should always work that you're getting out. So if you go to check and it doesn't work, that means you've done something incorrectly. So that's a good way to kind of check your work on a test. Make sure you're getting the correct answers. The next example here. So this example looks pretty tricky as well because of all of these decimals. So first thing I'm going to do before I do any kind of way of making this simpler is I'm going to get rid of these parentheses. That's going to always be our first step, is let's take care of those parentheses. So I'm going to have 0.04x and then 0.04 times 7,000. That would be something that you'd probably have to do off to the side. If not, you might be okay doing it in your head. You get 280, and then we have equals 680. So I'm going to just move this over so I give myself more space. So now we still have an equation that has some pretty big, well, not pretty big, pretty small numbers, and then we have some, some big numbers at the end. But the goal here is to show you a way to get rid of these decimals. So a trick that we can use is similar to a trick that we use for fractions, where if you don't want to mess around with combining like terms with decimals, a trick that you can use is to multiply by powers of 10. So basically, however many decimal places you have, that's going to tell you how many zeros you should have in your power of 10. So there's 2 decimal places that I want to get rid of, which means that if I multiply everything by 100, it's going to get rid of those 2 decimal places. So I'm going to multiply everything by 100. And you could have done this with the first step, and then you would have only been multiplying the 0.04 by 100 instead of distributing. But I find that if we don't distribute first, it's easy to make a mistake and not remember to multiply each piece by the 100. So I just recommend always distributing first. So anyways, now I'm going to look at 0.06 times 100. It's basically just going to move my decimal place 2 places over to the right. So then I get 6x. Same thing with the next one. You're going to get 4x. And then you're going to add 2 more zeros. So we get 28,000. And then over here, we're going to get 68,000. So now you have whole numbers that you're working with, which, can make your math a little bit easier. So next step is going to be to combine these 6x and 4x. So we get 10x. So we get 10x. And then plus 28,000 equals 68,000. Subtract over the 28,000. So we have 10x, those are gone, equals, so 0, 0, 0, 0, and 4, so 40,000. Divide everything by 10 is like thinking of removing a 0 from this. So we have x equals 4,000. And you would have gotten the same answer when if you would have kept the decimal. So it's definitely not mandatory that you take care of these decimals and get rid of them. It's just a strategy to try to help make the math a little bit easier. And then again, you always want to check your solution. Make sure you have the right answer. Okay? Couple other examples and then we'll be done with this. So next one is just a example that has a distributive property involved. So first up is always to get rid of those parentheses. So I'm going to have a negative 10x because I'm multiplying negative 2 times 5. Again, the next step is the one that you got to be really careful with. Negative 2 times negative 1. Make sure you're keeping those negative signs. So negative 2 times negative 1 is going to be a positive 2 plus 4x equals 20. And if you remember, I said you want to combine everything on one side of the equation before you start moving things over. So that means I'm going to want to combine my like terms. So my like terms meaning the 6 and the 2 and the negative 10x and the positive 4x. Combine all of that stuff first before you start moving things. So when I combine my 6 and my 2, I get 8. When I combine my negative 10x plus 4x, negative 10 plus 4, subtract and keep the sign of the bigger number, which is the negative 10, or the bigger absolute value, I should say, which is 10. So I get negative 6x, keep the x, equals 20. And now you want to get x by itself. So move over the 8 because you're trying to get x on one side and numbers on the other. So we have negative 6x equals 12. Divide both sides by negative 6. So we get x equals negative 2. And again, you would check your solution just by plugging it in. All right, let's look at the next one. So the next one here, same idea. First, you want to distribute. So we're going to get 15x, and then 3 times 1 gives me 3, equals 10 plus 15x. So again, get all of your x's on one side. So you can bring your 3 over. So we get 15x equals 7 plus 15x. You bring your 15x over. And then we end up with 0 equals 7. So this is a situation that I wanted to make sure I showed you. What happens when you get something like this? You get something that's not true. So basically I got something that's not true, which tells me that there's no possible answer that I can plug in to this equation to make it a true statement. So whenever you get a situation where something funky happens and terms cancel out, so see how my 15x is canceled out? I could have saw that right up here where see how the 15x's are on both sides? I know that they're going to end up canceling out. So since I got something that doesn't make sense or something that's not true, your answer to this question is just no solution. So it is possible. It doesn't happen a lot, but it is possible for you to get no solution with these. And then let's look at another situation. What happens the opposite? So what happens if you get a situation where instead of no solution, you get a solution where everything's true? So look at this one. If I distribute this 2, I have negative 4 plus 8x equals 8x minus 4. So you might be thinking already, I have negative 4 plus 8x and then 8x minus 4. This is exactly the same thing on the left as it is on the right. Those are the exact same expressions. So since I have the exact same expressions, the only thing that they really did was they used commutative property. Negative 4 plus 8x, well, it's addition, so you can change the order. 8x plus negative 4. So since I use commutative property here, I made a true statement, or I have two expressions that are exactly the same, which means for all real numbers, you can plug any number in for x, and this is going to be a true statement. Now, what if you didn't catch it right away? Well, you could start solving. Okay, so I solve, those cancel. I get 8x equals 8x, another true statement. You could even keep going. Okay, bring the 8x over, bring the 8x over. So we get those cancel. 0 equals 0, which is a true statement. So what that means is the solution for this type of problem is going to be all real numbers. And remember, you could have stopped at any step here. You didn't have to go all the way into seeing a number equaling a number, but just in case you didn't catch it right away, that's what would happen. You would get a true statement at the end, and then that means all real numbers. Okay, so those are all of the different combinations. If you get something that's not true, you get no solution. Something that's always true. So this is always true. You get all real numbers, and then if you get, just one x value, that's your solution. So those are the different possibilities.